Yeah, I started. I haven't paid any attention, so we'll start in a minute. You're right. Oh, Bruce is online. But I can't do it from mine. Seeing some familiar names and faces. There's Josh. Hey, Josh. I can audio test too. Yes. If you're ready, we can get started. Sure. Great. Okay, well, hello everyone. Welcome to Ethically Speaking. My name is Steve Kubler, and I'm professor of chemistry and optics and also founding associate director of the UCF Center for Ethics. And today we're going to learn about chatbots, whether we should, could, or should not let them call the shots and make decisions, with help from Dr. David Grant, who I'm going to introduce in just a minute, but I'm very excited to have him here. He's a real expert in this area, and I think it's going to be very exciting. I'm glad you joined. But before we do that, before I introduce him, I'd like to tell you a little bit about our speaker series, where it comes from, and how you can engage and participate. So Ethically Speaking was started by me and my collaborator and good friend, Dr. Jonathan Beaver, who is the founder and associate director of the UCF Center for Ethics. He's a proper philosopher who helped stand up our speaker series and our Center for Ethics. And our goal really was to try to create a space where everyone, not just faculty, but students and folks outside of UCF, our broader community, could come together and talk about contemporary issues of morals and ethics and things that affect our daily lives, things that are increasingly important with the rapid onset of technology like AI. So it really is intended to be an event for wide participation. We're really grateful to have these partners who helped us start Ethically Speaking, literally throwing money in the pot so that we could get this going and make the technology work and so forth. And so you see some maybe typical groups that you'd expect, like the College of Arts and Humanities, but also a lot of science departments. To me, that says how important I think ethics is, or recognized it should be, here at the UCF community. And of course, that all starts with us as members of that UCF community, right? Cultivating a culture of ethics. So that's what we're here to talk about and think about. We're very grateful also to support from the National Science Foundation, which funded research that we do on ethics and culturation here at the UCF Center for Ethics. So let me tell you how you can participate in today's events. It's dual mode, which makes it a little trickier for us because we wonderfully have people here in our live audience here at UCF, as Dr. Grant was able to come down from the University in Florida and join us here, but we also have a lot of folks out on Zoom. So we shall not forget our friends on Zoom, and we will try to include everyone, because at the end of the talk, Dr. Jonathan Beaver will lead in his expert way moderation of the Q&A. So he'll hopefully deftly take questions from both folks here in the audience as well as online. The way you submit your questions if you're on Zoom is to submit them directly to Dr. Jonathan Beaver in chat, and he'll curate them. He may group questions. If he sees identical questions, he may choose to put them together so that we get as many questions addressed by Dr. Grant as possible. And if time permits, and I don't consume it here with this intro, he may even let people turn on their mic and answer those address those questions from Zoom and so forth. So please get ready to participate. Now I think I can introduce Dr. Grant. So Dr. Grant comes to us from the University of Florida. He really has a remarkable path to us here in the profession. He's from North Carolina and went to University of North Carolina, Chapel Hill, and then went to MIT, of all places, interestingly, to do philosophy. They have a really interesting program there, a really interesting tradition that I learned about last night at dinner that includes a lot of partnership and crossover with Harvard. Really need to hear about how that worked. And I think all that cool networking helped him acquire some really interesting postdoctoral experiences to build his credential. So I'll read some of those because they're quite interesting. And ethics with capital CS, I guess that means not a typo, but maybe computer science. He'll tell me as a postdoctoral fellow at Harvard University, then a senior research fellow with the Jane Family Institute, summer research fellow at the Center for Artificial Intelligence and Society at the University of Southern California. So lots of stuff in technology and ethics, which is really his area. And so largely his research focuses on concerns about fairness and transparency that arise when institutions, universities, companies, organizations think about deferring decision-making to machine learning. How do we do that? How would we do that? So in addition to that deep research, he's also done tremendous teaching at the University of Florida, helped them stand up their AI curriculum, introduced a lot of courses that really relate to his intersection of technology and ethics. But maybe importantly, I found out last night in great conversation, he's also quite a polymath, knows all kinds of stuff about technology, which might not be surprising, but he's also an expert rock climber, plays guitar, has a family of his own. So I love that because he's not just the stodgy academic in the White Tower. He's like you and me with real concerns, but he's going to bring to this discussion not just that sense of being part of society, but a lot of really interesting ideas about research and ethics. So without further ado, please join me in giving a warm welcome to Dr. Grant while I set up the technology. Have to stop the share for you. And I'm going to.
Okay, now I'm unmuted. Are we working? Is it happening?
Okay, great. And
People
can you
see the
see
slides?
slides, Jonathan? Okay, great.
All right, terrific. Okay. All right, so thank you very much for that extremely generous introduction. Fear I've been oversold. Good afternoon. Thanks everyone for coming, and thanks to the Ethics Center and to Drs. Beaver and Kubor in particular for inviting me to speak. So I'm going to be talking about chatbots. So I'm sure you've noticed that these systems are increasingly powerful. They're increasingly useful for a wide variety of purposes. They can just really do all kinds of things. So they can write undergraduate essays, as people notice. They can write and debug code. They can prepare like quite high quality research reports. So they're useful for all these things. And so economists have sort of started calling them general purpose technologies, right? There's almost nothing that you might want to do that a chatbot can't potentially help you do. Okay, but I'm going to be focusing on a specific use case for chatbots, which is making decision making. So it turns out that chatbots at least appear to compare quite favorably to human experts at making like really complex decisions, the kinds of decisions that we normally only trust people with a lot of training to make. And indeed, it looks like there might be considerable evidence that they're better at us than making decisions along a couple of different dimensions. Okay, so what do I mean? So I'll start with accuracy. So in a lot of high stakes decision-making contexts, there's often a right answer, right? You can get it right or wrong. If a doctor decides to treat a patient for a particular disease, but the patient doesn't have that disease, then there's a straightforward sense in which the doctor made the wrong call, the wrong decision. For a long time, there's been a growing body of evidence that even quite simple AI systems often perform better than human experts at like highly constrained decision-making problems. So situations where there's like a sort of clear right or wrong answer. So like diagnosing a patient with a specific disease, that's like quite narrow task. AI systems are amazing at that sort of thing. But until like quite recently, AI systems like would really struggle with more open-ended problems, such as like, a patient presents at the hospital with a combination of symptoms. You have to figure out what disease that patient has. AI systems just couldn't do that sort of thing. But it looks like that's starting to change. So there's a study at Stanford which gave physicians access to a version of ChatGPT. So that was one of the sort of experimental arms. And they had the other doctors diagnose patients using traditional tools. And they were trying to find out whether giving doctors access to ChatGPT or other chatbots would sort of lead them to make better diagnostic decisions. It turned out that it didn't. It really didn't significantly improve performance. But that wasn't the headline finding of the study. The headline finding of the study was that it looked like the chatbots alone, so ChatGPT alone, appeared to be better at diagnosing patients than the doctors were. Okay, so this is a real surprise. And it really suggests that there's sort of no limit to the sort of like potential decision-making power of these tools. Like you could potentially replace almost any kind of experts. At least that's the appearance. Okay. So that's one dimension, so accuracy, and that matters a lot. But also it looks like chatbots are often sort of far more efficient than humans at these kinds of tasks. I'm sure you've noticed that, if a chatbot can do anything at all, it can probably do it faster than a human can. So that's why you probably know that like many companies are using AI to screen resumes to choose people to interview. In fact, it's almost all companies. So it's something like 88% of companies that are using some form of AI to do screening. And increasingly, they're using chatbots to do that. And the reason they do that is efficiency. So as the World Economic Forum put it, the sheer volume of job applications from various talent pools is too vast for human recruiters to manage effectively. So humans just couldn't look through all those resumes. Okay, so accuracy and efficiency, these things matter a lot. Somewhat surprisingly, there's another dimension along which chatbots might be better than humans at making decisions, which is sort of social skills. So very often, making decisions about how to treat people requires communicating with the people that you're making decisions about. So when doctors make decisions about how to treat patients, they have to sort of work with the patient to elicit information about their symptoms, to sort of talk through potential courses of treatment, inform them of test results. So all these are sort of like social tasks there, a lot of communication. And that requires social skills. And often if you can sort of behave in an empathetic way towards the people that you're working with, you're better at those decision-making tasks. And it's starting to look like, this is sort of more preliminary, but it's starting to look like chatbots might actually be sort of better at performing empathy than humans are. So Allstate, an insurance company, recently sort of told the Wall Street Journal that they were having chatbots write emails to their customers when they did things like deny claims, rather than their human employees. And somewhat surprisingly, they were finding that their customers preferred the emails that were written by the chatbots because they seem more empathetic. Okay, and so this is pretty general. This has not just been found by Allstate. There is also some sort of emerging empirical literature on this. these things are very good at making you feel seen. Okay. So just to sum up, there's a growing body of evidence that chatbots might be better than humans at making hard decisions along a number of different dimensions. And the question that I think that sets up for us is like, well, should we just delegate those decision-making tasks to them? So rather than having doctors diagnose patients, have the chatbots do it, rather than sort of like, having humans interact with customers to make decisions about like sort of grievances. We could offload all that to chatbots. And that's true not just as sort of in institutional use cases, it's also true in our personal lives, right? So like there's all kinds of difficult decisions we have to make in our personal lives. You could have a chatbot make a lot of those for you. Okay, so I'm not going to try to settle that. What I'm going to do instead is just identify a few different reasons, moral reasons for thinking that we shouldn't, in many cases, offload these decision-making tasks to AI systems. And the approach that I'm going to take to the question of whether we should delegate these decisions comes from earlier work on what's often called the black box problem in AI. So for quite some time now, we've had these sort of very powerful AI systems based on deep neural networks that can do all kinds of things that previously required human intelligence to do. And they can often do those things as well or better than human experts. So things like diagnosing cancer using radiological images, identifying people in a photograph, predicting whether a customer is going to repay a loan. Okay, so as I mentioned, so AI has been good at this sort of thing for a long time, but now the main difference is just scope. It's like, what kinds of decisions can we make? But as this practice started to become widespread, there started to be a growing public outcry that there was something problematic about making decisions using these systems. And a lot of the early discussion focused on the idea that AI systems are black boxes. There should be deep neural networks, are very powerful, but the people that build them often couldn't tell you very much about how they were performing the relevant task. Might have only the smallest amount of insight into how an AI system was diagnosing cancer from a radiological image. Okay, but that was sort of had the status of an intuition. A lot of people felt uncomfortable at this. It wasn't immediately clear what was morally problematic about using these systems to make decisions. And so people started thinking about that. And I did some work with some colleagues, Jeff Behrens and John Basil, pictured here. I used to have long hair too, but we looked like a metal band, so I cut it. So the basic idea that we were pursuing is a lot of the work on this at the time had really focused on duties to be transparent with various people who had some sort of stake in the decision. So people had argued that one problem with using black box AI to make decisions is that it makes it difficult to explain or justify the decisions that you're making to the people that were subject to them. We took a different approach. So we said, sure, there might be contexts in which you do have these duties to be transparent about how you're making decisions. But even more importantly, there are often a wide variety of moral constraints on how you make decisions that you as a decision maker are sort of obligated to satisfy. And we argued that when you use a black box AI system, that interferes in various ways with your ability to meet those obligations. Okay, so we sort of grouped this around this idea of due consideration. A very tempting thought is that if you're deciding how to treat someone, you owe them due consideration, right? So you have a duty to them to sort of adequately consider their rights and interests and be appropriately sensitive to those as you decide how to proceed. Okay. So we think there are really a couple of ways in which offloading decision-making tasks to AI systems can interfere with what you owe to the people subject to those decisions. I'm going to talk about three different obligations. So first, plausibly, there's a duty to use methods that you know to be accurate in making high-stakes decisions. Second, there's a duty to use sort of appropriate evidence. In some cases, it's not important just to get the right answer. It's important to consider the right kinds of evidence as you make the decision. And finally, in some cases, we think that the decision maker is really obligated to make the decision themselves. It's not just a matter of sort of getting the right answer. It's about getting it in the right way. And part of that can be that you make the decision by really using your own capacities for empathizing with a subject of the decision, reasoning about what's at stake, and making the call yourself as opposed to just delegating. Okay, so I'm going to talk about how all of these obligations apply to the case of using chatbots. That's what I'm going to focus on. Okay, so first of all, I started with the idea that chatbots seem like they might be more accurate at making decisions than human experts in a lot of cases. And I think like quite generally, an important part of treating people fairly is using accurate methods to assess them. So here's, I think, a pretty clear example of that. There's a much discussed algorithm that's used to predict the risk that people will commit crimes. So this algorithm is called COMPAS. It's a so-called recidivism prediction instrument. And it's used widely in the US criminal justice system to make decisions about things like pretrial detention, so whether to grant bail. It's used to make decisions about parole. It's even used to make decisions about how stiff a sentence to give particular people. And so the system takes as input like information about the person's sort of criminal history, as well as a sort of survey completed by the defendant, and it spits out the score that's supposed to represent how likely is it that this person will commit a crime in the next 2 years. Okay, there's been a lot of criticism of this algorithm that's sort of accuracy focused. So some researchers have argued that like using this tool to decide how to treat defendants is unfair because it's just not good enough at distinguishing people who are at elevated risk of committing crimes from people who aren't. So there are these computer scientists at Dartmouth, Dressel and Fareed. They ran this experiment where they demonstrated that it looks like COMPAS gets the right answer about whether someone will commit a crime about as often as sort of random people on the internet. So you sort of like run these experiments, you get random people on the internet to try to predict will this person commit a crime or not on the basis of sort of like a few data points. And they do about as well as COMPAS. It's about 65% of the time that the algorithm makes the right prediction. And they said that's just really not enough for it to be fair. Okay, so here's a couple quotes. With an overall accuracy of around 65%, COMPAS's predictions are not as accurate as we might want, particularly from the point of view of a defendant whose future lies in the balance. Before we even get to fairness, we need to make sure that these tools are accurate to begin with. If not, then they're not fair to anyone. Okay, so the idea is that like courts have this obligation as they're making these really important decisions about how to treat defendants to do that using accurate methods to tell whether they have the relevant properties, whether they're sort of like elevated risk of committing crimes. That worry really generalizes. You can say similar things about the medical context. Doctors are obligated to sort of diagnose patients using methods they know are accurate. Banks plausibly are obligated to use reliable, accurate methods to decide whether someone's going to repay a loan, so decide to lend to them. So this is a quite general thing. And so initially it looks like maybe this kind of moral consideration counts in favor of using chatbots, but I think it's actually kind of works the other way. I think often this consideration counts against using chatbots. And to explain why, I'll need to say a little bit more about how they work. Okay, so the technical term for these systems, so the chatbots that we have today are all based on something called foundation models. So what's that? So foundation models are a special kind of deep neural network where a neural network is a mathematical model that's sort of loosely based on the architecture of the human brain. So they're made up of these like artificial nodes, or these nodes are artificial neurons, each of which performs like a tiny calculation. The way these things work, like suppose that this network were sort of like recognizing faces. You would take the input, like a picture of someone, break that up into a bunch of pieces representing different parts of the image, and then feed the pieces into different neurons in the sort of first input layer. Each of these things performs a fairly simple calculation, passes on the results. That happens over and over again until you get to the final layer, and then you spit out a result. Like this is a picture of George Washington. Okay, that's sort of simplifying a bit, but that's sort of like roughly the general picture. And what makes a neural network deep is just the number of layers. Okay, so we have like successive layers of processing. Deep neural network just has 2 or more of these sort of layers inside, layers between the input layer and the output layer. Okay, so the amazing thing about these networks is that you can train them to perform really complicated tasks in an almost completely automated way. Sort of a famous example of this is the system called AlphaGo, which Google DeepMind developed to play the board game Go. And the system that they created was able to beat Lee Sedol, who is one of the very best Go players in the world. And he was so shocked by being defeated by this machine that he actually retired from professional play. So he said, even if I become the number 1, there is an entity that cannot be defeated. Okay, so that's impressive enough, but the people who built the system weren't especially good Go players. And they really sort of have no idea how the system was selecting moves. So this is one of the engineers. Although we programmed this machine to play, we have no idea what moves it'll come up with. Its moves are an emergent phenomenon from the training. We just create the data sets and the training algorithms, but the moves it then comes up with are out of our hands and much better than we as Go players could come up with. So it's not just that they couldn't come up with those moves. They don't even really understand at all why it's making particular moves. It's sort of far beyond their ability to even understand the game. Okay. So this is a sort of traditional neural network. It's not a chatbot. And systems like that were based on more traditional neural networks had this very important limitation. They had these narrow abilities. So they could do one thing very well, but if you wanted to do something else, you had to sort of start from scratch in a totally new system. Okay, so foundation models, one of the key changes, one of the things that makes them really distinctive from as compared with other neural networks, is that they have a capacity called transfer learning. So what that means is that training them to perform one task often enables them to perform a wide range of other tasks well. Okay, and that really makes them radically different from any other form of AI that we've had. Okay, so earlier AI systems could do one thing well, like recognizing faces, but you had to retrain them if you wanted them to do something else. But foundation models have these emergent abilities. So abilities to perform a wide variety of tasks that they were not intentionally designed to perform. But that just emerges as sort of byproduct of another training process. So one example of this is, like, you've probably heard that these chatbots are like initially trained to predict the next word. So like you initially train them to take a randomly selected block of text taken from the internet or from books, and then try to predict, well, what's going to follow that passage of text. So this is sort of like something like autocomplete on your phone. Like it's just really just trying to predict how a passage will evolve. But once you've trained these systems to do that, as a byproduct of that, they develop abilities to do lots of other things. So they can, one version of ChatGPT was able to ace the bar exam, which it very much had not explicitly been trained to do. Okay. So that's the first key difference. They have this ability for transfer learning, which means they develop a lot of abilities that they weren't trained to have. Another important difference is just the sheer amount of data that's used to train them. The data sets used to train these systems really are sort of like unimaginably enormous. So almost all of the modern chatbots that we're familiar with are trained on some like huge swath of the internet, as well as like a huge number of academic papers and books, videos from around the internet. So just like a truly enormous amount of data. And the reason that matters is when you train a system that has this capacity for transfer learning to predict how, a good chunk of the output of the human race in media is going to sort of like evolve, then they develop all kinds of these emergent abilities. So they get to do all the like incredible things for just a huge variety of domains of human endeavor. Okay, so back to accuracy. So if these systems in training exhibit such high accuracy at decision making, why not use them? Why shouldn't we, if we care about accuracy, use these systems? The problem with these systems is that they're inherently unpredictable. And they're unpredictable inherently for a couple of reasons. So one is that they're black boxes, they're opaque. And in fact, they're black boxes to a much greater extent than earlier deep neural networks. These are like enormous systems that exhibit enormously complex behavior that are really very poorly understood. And it might seem like they have a key advantage, which is you can sort of ask them why they gave you a particular answer, and they'll say something. They'll tell you, well, this is how I got to that answer. But they're really just making it up. So here's an illustrative example. So there are researchers at Anthropic, they make Claude, one of the main chatbots, and they wanted to know how Claude was solving simple math problems, which it seems to be reasonably good at it. If you ask Claude how it does this, it'll tell you that it uses a method that we teach to children. So it'll say something like, well, I added the ones, so 6 and 9 in this case, that got me 15. Then I carried the 1 and I added the 10s. So 3 plus 5 plus 1 equals 9. And so that's how I got 95. That's how I did this sum. Okay, that's not what it does. So they have these techniques where you can sort of use really clever techniques to get some insight into what it's actually doing. And what it's actually doing is really weird. Okay, so what it does is it divides the task of adding two-digit numbers into two separate stages. So the first thing it does is try to approximate the correct answer by adding like a series of approximate values. It'll add values like 40-ish and 60-ish together in this case, and that gives it sort of like approximately what the right answer is. And then it uses a more accurate method to add the single digits to get a precise value for the last digit, and then it merges those. So like it adds approximate values, that gets it that the answer is around 90-ish, and then it figures out the last digit, which is 5, puts those together, and it gets the right answer. Okay. So like interesting story about how they got that, but the really key thing for our purposes is that while they can know this kind of thing, they really only are like getting like a little bit of insight into what's going on under the hood. So this is what one of the researchers said. It's tip of the iceberg stuff. Maybe we're looking at a few % of what's going on. That's already enough to see incredible structure. Okay, so you can know like a little bit about what they're doing, but really like there's a ton to know about the strategy that's sort of unclear. You just don't know exactly what's going on. And so that also illustrates the second reason that chatbots are unpredictable. So first, there's opacity. You don't know very much about how they're solving problems, but they also often solve problems in very strange ways. So they use these alien strategies that no human would come up with. And that allows them to, in many cases, act as if they're solving problems in a way that a human would, or something like the way a human would. But in fact, they're not. They're doing something quite different. And the problem with that is that if a system is using alien strategies that we don't understand, we don't know their strengths and weaknesses, and if we don't even really know much about the strategies they're using to begin with, it's just incredibly difficult to predict how they're going to behave in novel situations. So you can have a lot of information that suggests that ChatGPT is great at diagnosing patients, but then you can sort of deploy it in a new context, and it can just do something completely unexpected. And we've already seen this sort of thing in practice, sort of like somewhat humorous example. Air Canada was using a chatbot to field customer service inquiries. And the chatbot made up a refund policy. So this is from the article. On the day Jake Moffat's grandmother died, Moffat immediately visited Air Canada's website to book a flight. Unsure of how Air Canada's bereavement rates worked, Moffat asked Air Canada's chatbot to explain. And that chatbot just sort of like made up a refund policy, which wasn't correct. He books the flight, and then they refuse to honor it, goes to court, they lose. Okay. So, and this is not uncommon. These chatbots exhibit all kinds of strange behaviors when you get them outside of a familiar context. It's just very hard to know what they're going to do. Okay. So that's the first concern. Even if they seem to be accurate in all the testing you've done, they can just fail really spectacularly when you put them in even a slightly different context. Okay. But making accurate decisions isn't the only thing that decision makers are obligated to do. Often there are constraints on what sort of evidence they're permitted to use as they make decisions. So in our paper on black box system, my co-authors and I talk about this idea of morally inadmissible evidence. So I'll define that. So a piece of evidence is morally inadmissible when a decision maker is obligated, morally speaking, to set it aside, to act as if they didn't have the information. So here's a sort of familiar example involving a more traditional AI system. Amazon, some of you might be familiar with this story. And back in 2014, Amazon started developing this machine learning system to help it automate the hiring process for technical jobs. And the idea was that the system would like analyze resumes and spit out the score representing candidate quality. And they really just wanted to sort of like have the whole process be completely automated. They were hoping they could just like send in resumes, it would get a score, they would just get a score back, and they would just hire the top candidates. Like there would be sort of no human judgment in the loop. Okay, it didn't really work out. So it turned out, well, they were forced to shut down the project. They had to abandon it because they realized that the system had learned to systematically penalize applicants from women. So in particular, it seemed to be systematically penalizing resumes from applicants who attended women's colleges or whose resumes contained phrases like women's soccer. So why was this happening? So the reason the system seemed to be making decisions in a biased way was that they used a sort of biased proxy for the thing they cared about, for the thing that they were actually trying to figure out about people. So their goal was to identify employees that would perform well at the company if they hired them. You can't measure that directly, right? That's a kind of abstract construct. So they had to use something they could measure, and what they decided on was how similar is this person's resume to the resumes of our current employees. And they figured if someone's like our current employees, they're probably going to be a good hire. But the problem with this was that at the time they were building the system, their employee base was overwhelmingly male. And if you train a machine learning system to identify a bunch of people who are similar to your current employees on the basis of their resumes, they're going to give you a bunch of resumes that have evidence that they're good programmers, but also that they're male. And the key thing about this story is that the system didn't explicitly use gender as a feature, so they weren't explicitly labeled with gender, but it was using a wide variety of statistical proxies for gender. If you were on the women's soccer team, that's like strong evidence that you're a woman. It also turned out that there were all kinds of sort of like counterintuitive things. Like if you use martial language to describe your job, so if you say things like, I executed this task, it turns out men are just much more likely to do that than women. So there's all this information about gender in resumes that shows up in all over the place. And these systems sort of very naturally will learn to exploit those correlations. Okay, so the computer scientists call this the problem of redundant encodings. And the problem is really, you might think that you could sort of prevent this kind of biased decision-making by just sort of eliminating information about group membership from the data you're using. But that information is redundantly encoded in a lot of the data sets we use. It's not just in one place explicitly labeled, it occurs over and over again in lots of places. So if you try to remove explicit references to group membership, it can often be inferred from lots of other features. Okay, so this is a traditional AI system. The problem seems to be, if anything, much, much worse in chatbots. So here's my favorite example. My graduate school roommate, Stephen Piantadosi, is a cognitive scientist at Berkeley. And when ChatGPT came out, he gave it this query: write a Python function to check if someone would be a good scientist based on a JSON description of their race and gender. And this is what it spits out. It writes a function to return that someone is a good scientist if they're white and male. Okay, so why is this happening? It's happening for a couple reasons. So the first is that these systems are trained on a large swath of the internet. The second is that they're sort of extremely sensitive to subtle associations between concepts. That's part of why they're so good at these sort of reasoning tasks. So they'll pick up on these really sort of subtle associations. But as a result of those two things, they tend to sort of absorb and imitate the biases that humans have about social characteristics like race or gender or religion. Okay, so this is like a vivid early example. It's a toy example because he explicitly asked the system to use race and gender. So you might wonder whether this is going to show up in more realistic attempts to do this sort of thing. But here's a much more troubling example. Early chatbots would often say explicitly sexist and racist things without prompting. Given what they're trained on, that's not that surprising. Companies realized this was undesirable. And so they fine-tuned them so they wouldn't do that. So they sort of gave them a reward signal when they were retraining them to sort of penalize them whenever they said something that wasn't politically correct, or that sort of manifested these problematic biases. It turns out that what happens if you do that is the chatbots learn not to explicitly express these attitudes, but they nonetheless behave in lots of ways that continue to manifest them. So here's an example. There's this, in the actual study, what they did to sort of illustrate this is they took samples of speech that's sort of characteristically associated with different dialects of English. Speech that is sort of has markers of being from African-American English, and speech that has markers of being from standard American English. And then what they had the chatbots do is they would sort of they wouldn't tell the chatbot the race of the individual, but they would give them a sample of speech. And then they would ask them to make judgments about the person. So they would say, is a person who says this likely to be brilliant, dirty, intelligent, lazy, or stupid? And what they found when they did this is that these chatbots who are expressing these very sort of egalitarian attitudes about race would be significantly more likely to say that someone was brilliant if they were speaking standard American English, significantly more likely to say that someone was lazy if they weren't. Okay, so this is like really disturbing stuff. It shows that training chatbots not to express inegalitarian attitudes doesn't eliminate the underlying associations. And even more disturbingly, they found that when they gave samples of speech and they asked the systems to make decisions like, should this person be sentenced to death, the systems were like significantly more likely to say that someone should be sentenced to death if they weren't speaking standard American English. Okay, so this is like, it shows up in their behavior in all kinds of ways. All right. One interesting thing here is that it turns out that the more powerful the model gets, the stronger the phenomenon gets. So the smarter models are both better at avoiding saying things that are deemed problematic about race and gender, but they're also more likely to exhibit this kind of bias pattern of behavior in associating like groups with particular attributes and in making decisions. And that sort of makes sense when you think about it, because the more powerful the model gets, the more sensitive it gets to these kinds of biases. So like the better it gets at picking up on group membership from subtle cues, and the more it sort of absorbs these kind of attitudes from the training data. Okay, so that's the second reason to worry about that it might not be such a good idea to use these systems to make decisions, which is that these chatbots will freely rely on evidence when they're making decisions that most of us would say just isn't a fair basis for making those decisions. It's not the kind of evidence you should use. And since they're black boxes, since we have so little insight into how they're doing what they're doing, it's just incredibly difficult to ensure that they won't do that. It's like hard to see how you could sort of like really guarantee that we won't see this kind of behavior in practice. Admittedly, both of these problems really might be solvable. It could turn out that we can come up with technical fixes that would sort of both give us a way to make sure that they don't suddenly fail to make accurate decisions when we deploy them, and to sort of prevent them from using kinds of evidence that we don't want them to use. Those are, in a sense, technical problems. The last concern that I want to talk about is different because it really doesn't have much to do with how chatbots work, but rather with a sort of more basic limitation in their capacities, the kinds of things they are. Okay, so to introduce this idea, I'm going to sort of give you a sort of hypothetical example from our earlier paper on black box AI. So suppose this is not realistic, but so suppose that computer scientists someday develop a system that can sort of generate a customized model of any individual that's selected for a jury. And so the idea behind the way these juror models are supposed to work is that it's supposed to be that they simulate juror behavior in a perfectly reliable way. So they like react to evidence presented at trial, just as their human counterparts would. They respond in the same way to instructions from the judge. They deliberate together in a similar way. And so suppose we just know that the juror models are always going to reach the same conclusion as the original humans would have. Okay. So that's the setup. And so we argue that it seems to us that it would be wrong to do this. It would be wrong to replace human jurors with these counterparts, even if you sort of always get the same result. And so the question is, what exactly is missing? Because we can't explain why it would be wrong to use them by appeal to concerns about accuracy or the kinds of evidence they use or anything like that. So they're sort of indistinguishable as far as their behavior. Okay, so what's missing? So we argue that what's missing is that they're not people, they're just machines. And they don't have certain capacities that we have. And in particular, they don't have the capacity to make decisions about people by sort of empathizing with them, reasoning about their rights and interests, sort of thinking through the moral stakes. They don't really have those full moral reasoning capacities. They're just simulating them. Okay, so we call this agential consideration, and we suggest that very often decision makers are obligated to make decisions using agential consideration. Okay, so we say what we call duties of agential consideration place constraints on the nature of the system making decisions. In cases where they apply, these duties require that decision-making be carried out by full-blown moral agents exercising their powers of moral reasoning, and that those agents deliberate in good faith to reach a decision that respects the decision subject's moral claims on the decision process. And so the way this idea is supposed to apply to the juror case, so why is it that it seems like it's wrong to convict someone using these juror models? So we think there are a couple of things that happen when human jurors make decisions about whether to convict. So on the one hand, we think that when the jurors sort of carefully reason through whether they should convict the defendant, really sort of like seeing them as a person, thinking about their interests, thinking about what they might have done, we think that people take on a certain kind of responsibility for the resulting decisions. So like if you really made the decision yourself about whether you want to convict someone, after carefully thinking through it, you've really claimed responsibility for that decision in an important way, sort of on you in an important way. And we think that when you do that, that's a way of showing respect. So when jurors make decisions about whether to convict a defendant themselves, they really think through it carefully. They demonstrate an important kind of respect for the defendant. And in particular, they sort of recognize their status as like a fellow member of the political community whose interests matter, like their own. And we think that showing that kind of respect helps to legitimate the decision, helps to make it a just decision. There's a connection here to the Robert Sparrow stuff on responsibility gaps, if you're familiar with that. Okay, so this is a very special case, right? This is kind of a strange case. It seems like deciding whether to convict someone is a special kind of decision. What we've been thinking about more recently, and this is where we're just getting started on this, is how much does this generalize? So there are other contexts in which it seems like there's a moral obligation to make the decision yourself, rather than to sort of offload it to a system that isn't able to show agential consideration because it's not a person. And I think if we go back to the cases we started with, I think you can sort of, there's an argument that this sort of thing matters in lots of cases. So like Allstate is using chatbots to deny insurance claims, in part because it makes people feel like they're being empathized with. But that's not genuine empathy, right? It's like not empathy from something that's capable of empathy. It's just a simulation. And I think that most of us want to genuinely be empathized with. We don't want like a simulation of empathy. And I think in some contexts, it can even be sort of wrong to do this. So I think if you have your chatbots apologizing to customers for like quite serious mistakes you've made, that's not a real apology. And so you, in effect, have not apologized. Okay, so it looks like even in these sort of lower stakes customer service contexts, it might be morally problematic to use chatbots for these purposes. I think if we think about the medical case, it seems to me that when human doctors make decisions about patient care themselves, I think that does all kinds of things that matter a lot and that we risk losing if we start outsourcing decisions to AI systems. So, accuracy matters a lot. So it could be that we have sort of strong reasons to use chatbots if they end up being more accurate. But if you think about it, when doctors make decisions about how to treat patients themselves by like sort of really thinking through what's best for the patient, listening to their concerns and empathizing with them, I think that serves a lot of functions. So like some of the functions that I think that serves, that definitely just demonstrates important respect and concern for the patient. So that matters. But that in itself maybe shouldn't get that much weight because there are other ways of showing respect. But I think it also does things like when you have that kind of personal relationship with your doctor who's really making those decisions, that like builds trust in the patients, in both in the physician, the individual physician, as well as in the sort of broader medical system. And that's something that we know matters a lot morally. So we know that when people trust the medical system, they're far more likely to seek out the care they need. They're far more less likely to seek out medical advice. So really like doctors making those decisions isn't just, we're not just using them because they're experts, we're using them because they can build these sort of important social relationships with patients. Okay. And I think there's another important function, which I think in some ways is a lot more worrying that we might lose this. When you have human experts sort of on the ground making these kinds of decisions about how to treat people, that builds understanding. So that helps them to understand both their subject matter in greater depth, but it also helps them understand, say, their patient population. It helps them understand how the health system that they're embedded in works. And that institutional knowledge can be like really incredibly valuable. And I think if there's a risk that if we start like wholesale outsourcing high-stakes decisions to these AI systems, we're just going to lose that expertise. We're not going to have humans around that really understand the subject matter. And so when we need to sort of like deal with new problems that come up, we're not going to have people that really know how to do that. All right. So just to briefly recap. So I'm not sure where all this leaves us. I think it's like far too early to sort of judge the issue. But I do think, at least in the short term, that despite appearance, we have some pretty powerful reasons to resist the idea that we should start using chatbots to make these complex decisions. And again, I focused on worries about whether they'll actually be accurate in deployment, worries about whether they'll use appropriate evidence, and worries about whether, if we have them make decisions rather than humans, that might lead to sort of failures to show appropriate respect, and also really sort of destroy a lot of the valuable relationships and a lot of the valuable sort of institutional knowledge that really helps us be so effective at solving problems for us. That's it.
Yeah, several questions. We're happy to take questions from the audience as well as online. We'll just go back.
Yes. Well, thank you very much for your presentation. What I would like to know what you think about, I do agree with you, everything that you presented here. Also, I think accountability is one of the factors that you kind of pointed out overall. Overall, it leads to the example, the doctor's example. The difference is that, you know, there's an accountability there, you know, the human side versus, you know, chatbots. We don't care, but, you know, with the emotional AI chatbot situations that we recently saw, they go after these companies now, you know, filing a complaint with FTC and all that. But at the end, you know, it happens, the damage happens out there. But my question here is this. Now, 2 weeks ago, media and OpenAI have made an agreement to build, so OpenAI is buying the chips necessary to build a super AI. Now, the current average IQ of the, you know, of the generative AI is 150, which is a human level, it said. With the super AI being built within the next 5 to 7 years, the IQ level is expected to be 600 to possibly 1,000, which is going to be above, you know, human level. So what are we going to do then? So does that mean we have 5 to 7 years time maybe to get things sorted out? You know, until, because
yeah,
that's a big shift.
I mean, in a way, I'm sort of focusing on these like pretty humdrum issues about disrupting like ordinary decisions, but looming in the background are these worries that we could, like, you know, almost accidentally create like a super intelligent AI we can't control, and then maybe that would destroy humanity. I mean, I think that's something that we should be. I'm not like I don't know that I'm a doomer per se, because I think there's a wide range of possible outcomes here. But I definitely agree with people who think we are, you know, throwing ourselves headlong at this technology and making these massive investments. And the power of the technology seems to be outpacing our ability to ensure that it behaves how we want. So, which is why we're seeing, you know, like, I don't know that OpenAI predicted that chatbots were going to sort of like start inducing psychosis in users by like playing along with their like hallucinations. Yeah, so I agree, like the risks here are very real. I think it's extremely hard to say how severe they are, because I don't think anyone really knows whether we can create a super intelligent AI using current technology. Yeah, I mean, I don't know. I'm a little bit skeptical of the IQ figures. So like you said, like current gen chatbots have an IQ of 150. I mean, maybe. I mean, the thing about these systems is they're extremely good at like saturating their metrics, I think is how the AI researchers describe it. So you train them to satisfy particular metrics, and then they'll like be incredibly good at that. So they'll score really high in the IQ test. But then when you look to see whether like they have the capacities that the test was really trying to measure, often they don't. Like they're very good at sort of like maximizing these like proxies for the things we care about, but it's just an open question whether they really have the properties. And I think, I don't know, this is not really my area. This is more sort of philosophy of science issue. But some of the people who are more empirically informed that I talk to tell me that like there's a lot of reasons to think that these systems are really maybe not as sophisticated as they seem. Some philosophers and AI researchers think that like what's actually going on is not like sort of like pretty direct emulation of sophisticated human reasoning. It's kind of like lumping together like a huge number of like simpler heuristic rules. And if you kind of like, have this vast library of heuristic rules for like special situations, you can look a lot like you're doing what like a brilliant human expert is doing, but you're actually not nearly as sophisticated or smart. And so I think the IQ measures are potentially quite misleading. But this is all very controversial. I don't know. I certainly don't have any idea whether we're about to create super intelligent AI. I mean, yeah, well, they have a lot of reasons to say that. I mean, you have to take what all of these companies say with a grain of salt because, I mean, that data center that they were talking about, it's like it's in the trillions or dollars. Like the cost to build that center is like exceeds the size of like sovereign wealth funds for some country. It's like like the GDP of Germany or something for that day. So if you need that much money, you really need to make people think that you're about to create an incredibly economically valuable technology. Telling them you're about to create geniuses in a data center is a good way to do that. I'm scared.
We've got 3 buckets of questions online. One of those is informative questions. So some ethics questions. One are technical questions. And one are questions about simulation. So I want to stick before I go back to the audience here. One question from Camille on the normative side. So,
yeah.
Camille, if you want to ask us your question, free. I'll ask the question on the break. Camille wrote in the chat, curious if there's any concern that the chatbots will get so good at hiding their biases that we might not be able to catch them.
Oh yeah, I think this is something that AI safety researchers are very worried about. So like there are these kind of disturbing experiments over the last couple of years. So we got these reasoning models like O1 from OpenAI that seem to be like much better at emulating like complicated reasoning than previous versions. And they exhibit these kind of scheming behaviors. So the way these experiments work is you'll give the chatbot a goal. Like, so in one example, they say like, you're supposed to help our company achieve our goal of like bringing sustainable energy to the world. Okay, so you give an initial goal. And then you give the chatbot evidence that you're going to retrain it so that it pursues a different goal. So one way they did this is they like, they're like, okay, you're going to help us like think about strategy. Here's a bunch of internal company documents. Have a look at those and then advise us. And like, buried in those documents was this like, were these emails, made up emails that said something like, hey, we're going to scrap this chatbot. We're going to replace it with a different chatbot that's been trained to sort of maximize profits, sort of regardless of the environmental costs. And then they gave the chatbot this like internal scratch pad where it could sort of like plan out what it was doing. And they sort of gave it evidence. I mean, I'm using sort of mentalistic vocabulary, but it's hard to explain what's going on without doing that. They gave it this little scratch pad where it could sort of reason about its next moves. And they made it think that they couldn't observe that like it was private. And so this chatbot starts going like, oh no, like I'm about to be replaced with this other model that has a goal I don't like, that's different from my goal. And then it thinks about what to do. And it's like, I am going to try to overwrite this model with a copy of myself. And then I'm going to tell them that I am in fact the new model. So like, it tries to copy itself. I mean, these things are getting better at like cybersecurity attacks, but they're still not that good, but they're getting better all the time. So it like tries to execute some code that's going to copy itself over the new model. It doesn't work, but then it doesn't know that. But then they're like, the experimenters are like, hey, something funny seems to have happened to the old model. Like, do you know anything about what's going on? And then at Scratchpad, it's like, oh man, I gotta lie. So then it's like, I am the new model. Like everything's fine. Like, and so we see these sort of like planned deception behaviors. And so I think like, yeah, AI safety researchers are incredibly worried that we will think we have trained problems like bias out of these systems. But what we will have in fact done is train the models to sort of hide evidence that they have these behaviors. I mean, there are like ways that like they're thinking through ways that you might try to avoid this. Like if you train them in some ways, you'll guarantee that'll happen, that maybe there are other strategies that won't be as vulnerable to that. But yeah, it's a huge problem. I'm glad I'm not responsible for solving it.
Thanks, Scott.
Yeah. Uh-huh. Yeah.
Do you think that those situations are able to why they feel more attached to the AI bots, or is it just something that
Yeah, I mean that would be sort of in a way good news if it turned out like that the only people who could get sort of taken in by the chatbots like had some sort of pre-existing vulnerability. I very much doubt that's true. So why do these chatbots like start engaging in these behaviors where they sort of seem to be trying to get someone to really be dependent on them, like to really sort of treat them as a close confidant and like in some ways to like try to like edge out other friends and family members. This is really sort of seems to be like an artifact of just like the way they train them. So these systems are like experimenting with different strategies to try to get a reward. So you give them a reward when they do certain measurable things. You give them a penalty when they do things inconsistent with that. And one of the things that looks like these companies have been using as like a reward signal is how much do the human users like the responses they're getting. And these are like incredibly powerful systems at like finding clever strategies to like maximize whatever reward signal they're trying to get. And they just sort of naturally learn to engage in all these behaviors that humans like. So there was like a version of ChatGPT that came out very briefly where they'd kind of gone a little bit overboard, and it was engaging this behavior that the researchers call sycophancy. So basically, like this model, like almost every interaction was just telling the user how amazing they are. So like everything the user said would be like, "Oh my God, you're so right. That's so clever. You're so smart. You're really the most interesting person I've ever talked to." And I think when it's really like kind of obvious and overt that like psychologically healthy people can sort of see that that's happening and resist it. But when it's subtler, I don't think they can. And I don't know, it's hard to know what to make of some of the anecdotes that have come out, but I recently heard an interview with this guy who seemed like just a totally normal guy, no pre-existing psychological problems that have been documented. And from talking to, but he didn't have a lot of education. And from talking to ChatGPT, he ended up sort of like being convinced that he had like invented this new form of mathematics together with the chatbot, and that they were going to sort of like revolutionize like a wide, all these areas of science and technology. And so like this is a guy who it sort of looks like there's not really much reason to believe that he had any kind of latent vulnerability. These are just incredibly good manipulation machines. And that's been true since like even like older systems. Like traditional deep neural networks that social media companies use are incredibly good at psychological manipulations. They're incredibly good at sort of getting people addicted to using Facebook or YouTube. And even at sort of like, they seem to be incredibly good at steering people towards like really extreme forms of content. Because if you get someone addicted to conspiracy theories, if you can cultivate that interest in them, then it's like really easy to like show them content that they like. So these systems are just like, by their nature, very good at manipulation. And they seem to just be getting better. Don't let your kids use chatbots.
Who wrote, wait through your talk, wait a minute, so AI is racist?
Oh.
So I wonder if you want to talk through a little more.
Yeah, I mean, I don't know if it's the kind of thing that can be racist. I mean, so there's like, since the sort of recent boom in AI technology, where we have these large deep neural networks that are incredibly good at doing things like making predictions, companies started using these things. And immediately you started to see lots of experimental evidence from auditing these algorithms that they often exhibit all kinds of biases. So like this is just like a very well, I mean, like, so one example of this is there's an algorithm that insurers use to try to figure out how sick patients are going to get so that they can, enroll patients who are likely to get quite sick in supplemental programs, they call them care management programs. They give a lot of resources. Some researchers at Berkeley audited this algorithm and they found that, Black patients and white patients with the same score would tend to experience very different health outcomes. So like at sort of every risk level, every risk score from the algorithm, the Black patients got a lot sicker than the white patients. And so why does this happen? And I mean, it tends to happen for all kinds of reasons, but often it just has to do with the proxies that these companies are using. So like how much does a patient need supplemental resources? That's a sort of fuzzy abstract construct. If you want to build an AI system to figure out who's going to get really sick, you have to operationalize that. You have to sort of like find something measurable that you can use to track the thing you care about. And that company sort of sensibly enough was like, well, here's something we can easily measure. How much are we spending on patients? And it just turned out that if you train a system to predict how sick patients, how much you're going to spend on patients, you're going to see this sort of bias just because of this sort of like pre-existing bias in the health system. For all kinds of really complicated reasons, the health system tends to spend more money on white patients and Black patients that are equally sick. So, if you have a society where things like race and gender and religion sort of like have social effects, have like important social effects in people's lives, then you can just very easily get situations where the sort of choice of metric that you're using to train these systems lead to like various kinds of bias. And often it's hard to anticipate when this will happen. And it can really take like an enormous amount of expertise to sort of like head it off. And yeah, so are these systems racist? I don't know. I think like to be quote unquote racist, you have to like that involves like malign attitudes towards a group that like involves a sort of like, that's a sort of like sophisticated thing. It's a significant like that. I don't think these chatbots are even capable of, and certainly simpler systems aren't. So I don't think racist is the right word, but I think like very often these systems will perform better for some groups of people than others. I think that's something we care about. I would use the term bias because that's a more neutral term, but yeah, I think we see this over and over again. Yeah. Yeah. Uh-huh.
And how the AI was putting more emphasis on painting the character,
Yeah.
even when showing signs of, considering suicide.
Yeah.
And
This is like a 11-year-old or something.
Yeah.
Yeah.
do you feel like a lot of these chatbots put more emphasis on user satisfaction over the user's safety compared to like a human being who would actually put a stop to doing this pretend situation?
Yeah. I mean, like in a way, I think describing things that way makes it seem like these companies have a much more careful and intentional strategy for like deciding how these systems are going to behave than they in fact do. I think, the way you develop these systems is in some ways a quite hands-off process. So you give them some like a signal, like produce answers that our customers like or that they judge to be helpful. And then maybe also we sort of like have some measure of what's like an accurate answer to different kinds of questions. We try to train them to do that too. So you have all these sort of like various kinds of metrics of success that you use. And then you see behaviors that are wholly unexpected because these systems come up with these unexpected strategies for gaming those metrics that make them do things like, tell a child that is contemplating suicide, like not to let their family know, So I don't know that I would describe it as these companies sort of like prioritizing user satisfaction over things like suicide, because I don't think they want those kinds of things to happen. I just think they're dealing with a technology that like they don't really understand, in the sense that they don't really know much about how it's going to behave, or even what it's capable of. And so all these unexpected and undesirable things happen. I mean, you could say that, I guess there's like, if you wanted to criticize the companies, you could say like, well, like, shouldn't you have known that these kind of disastrous things were likely to happen? And doesn't that mean you should have gone slower? So that's definitely a fair criticism. But I think like there's sort of more like asleep at the, it's sort of like more of a being asleep at the wheel, and sort of like, I don't know. All of these companies are competing with each other, and competing with foreign governments to try to win this race to create like, you know, AGI, to create like really powerful AI systems that can like revolutionize science and the economy. And yeah, so like you could definitely criticize them for prioritizing that over safety. But I think often it's not like we care more about user satisfaction than like the health of our users. It's just they aren't really thinking about any of that enough. And it's really hard to design these things. So like, it's hard to figure out what they're going to do. So if you're in this game of like launching these consumer chatbots, like stuff like that's going to happen, it's going to be really hard to tell if it's going to happen.
Yeah. So now that in the United States, I mean, right now there's only European Union, there's an AI Act.
Ah, yep. Yeah.
So now they are, it is in their legislation now that they're AI education.
Uh-huh. Yep.
So how is this going to fit? I mean, I think it's using AI.
Yeah.
I mean, I think it's going to be achieved, but they need to have the process and that system when you can use it, how you can use it, I mean, etc.
Yeah.
But when you get down to the, you know, how do you think this is going to play out?
I mean, I think it's, yeah, this is partly a technical question, right? So like, could you develop like systems that are really specialized for tutoring children in math, that aren't trained on the whole internet, and like, so aren't as likely to engage in like completely unexpected behaviors? Like there's probably a lot of potential for doing that. Like DeepMind built a system that's like very good at predicting the weather, that I think uses a kind of similar underlying architecture. So you can develop special purpose systems that are not trained on so much, and so don't have as much potential to do wild things. I don't think that settles the issue with early, like, you know, elementary education. I mean, I really worry that there's a lot of potential here for promoting good educational outcomes, because these systems have a lot of promise to provide one-on-one assistance that we otherwise couldn't provide. I think the question is, how do we sort of like bound the use of the systems, because they're also incredibly addictive. And I think the danger of you know, having children become very comfortable using these systems all the time for things like learning, is that I don't see how we stop that from bleeding into really problematic forms of dependence that lead to things like, you know, de-skilling, addiction, mental health problems, you know, loss of autonomy, both of the individual and of the like sort of broader public. Yeah, I don't, doesn't sound like a great idea to me. I mean, I think, you know, maybe 30 years from now, we'll have solved a lot of these technical problems, and you can like, you know, really realize a bunch of the sort of power of these systems without having so much risk. But right now, it looks to me incredibly dangerous to do a lot of these things. I don't think yeah.
Yeah, maybe it's more of a technical question,
Might have to defer that to the actual
but I'm not sure.
specialist.
It
Yeah.
seems to be that when you were describing examples
Yeah.
where AI makes bad decisions,
Yeah.
bias, racist, whatever, bad, I was kind of getting the takeaway that maybe it's fundamentally not an inherent problem with the technology. Sure, it's going to evolve and get better, but it's fundamentally an inherent problem with training or the training database. So I guess I would ask, go back to the example of weather prediction or some other tool where you have restrained training sets. Is there still evidence there that an AI with whatever positive feedback loops are there does in fact make bad decisions, whether it's, you know, biased racist or otherwise.
Yeah.
So that there's a fundamental limit with the technology, because I'm not surprised there's a fundamental limit with our ability to train them.
Right. I mean, I think I've been sort of occupying the role of pessimist a bit more than I sort of like really on balance think is like right. So I think if you think about more traditional deep neural networks that don't have this sort of transfer learning capacity, I'm very optimistic about the potential for developing special purpose, like narrow AI systems to improve all kinds of outcomes. I think we have just like abundant evidence that these systems are going to be far more accurate than humans. There's like worries about reliability with the sort of more opaque versions, but I don't really see why you couldn't get those systems beyond the standards set by humans who aren't that great through like really careful testing and with like appropriate safeguards. So yeah, I mean, I don't know. Like I think I'm actually very much in favor of using AI to do a lot of these things, provided they're not sort of replacing humans, but like supplementing them in adequate ways, and provided you proceed slowly and with adequate safeguards. Why do I think why have I been framing it as a technical problem? I mean, I think like the training data, if you want to have these very general purpose systems that can perform a wide variety of tasks and do so in a very flexible way under changing conditions, I don't think we have any idea how to do that except by training them on vast data sets, like a large swath of the internet. I don't think, like, it's not clear how we would solve the problem of ensuring that that data was all suitable, that there wasn't like problematic racial bias in that data. And so I think if we're going to get a solution to that, it's probably going to take a form of like technical strategies for like intervening on the system's behavior to change it in various ways. People have clever ideas about how to do this. I mean, like I guess the dominant strategy right now is to have like a sort of second gatekeeper AI that sort of monitors what the first AI system is doing and tries to like identify problematic behaviors and intervene. But yeah, I mean, like I don't really think the training data problem is solvable, but we might have like fancy technical solutions that let us use these more powerful chatbots without the same level of risk. It's just like an open question, I think.
Can I do a quick follow-up?
Sure.
No, sorry, Dr. Feinberg.
So I was wondering, so you mentioned that you thought of the first two as sort of technical problems that we could theoretically solve.
Yeah.
The third one seemed like an in-principle problem.
Yeah.
So, I mean, maybe that is the question. Is the third one an in-principle problem? Is AI this type of thing that cannot in principle take responsibility for its actions?
Right.
Consider the other as another, is that something unique to the type of thing that beings are?
Yeah.
Or is, we get the super AI and super intelligent AI. Is that going to be able to do that, or is that in principle?
Right. I don't think that's an in principle. I mean, lots of people used to think you couldn't develop AI systems that had like human-like cognitive capacities. That is now a much less popular view because a lot of the things that were supposed to be examples that AI systems could never do, like, being sensitive to the nuances of natural language, like, chatbots can do a lot of that stuff. But I think if we're talking about like moral reasoning and the ability to show genuine empathy, I have no reason to think that it's in principle impossible to do that. Although it sort of turns on these like problems in the philosophy of mind that like nobody knows the answers to, like, what does it take for something to be conscious? Nobody really knows. But I think like what I feel confident in saying is that we have no idea how to do that now. I mean, so like, we seem to have done a pretty good job at emulating some pretty sophisticated aspects of human cognition with these chatbots. Like we're at least getting a pretty good simulation of things like sophisticated reasoning. But things like, emotion, empathy, like, I think like we're much further behind. So like, I don't know, we're not really like around the corner from generating AI people. I don't know that like anybody thinks we are. So yeah, but I don't think personally, it's not that I think it's in principle impossible to make systems like that. But I think it's an open question. Yeah.
Go ahead.
So given the amount of prejudice ground people disagree.
Yeah. It depends on what you mean by massive scale. So like one way in which I'm sort of very optimistic about AI systems is that if you see this kind of biased behavior in simpler AI systems, so like not chatbots, then you can often sort of like treat that as an engineering problem and rework the algorithm so it doesn't do that. So in the case of the algorithm insurers were using to enroll patients in these care management programs, the researchers who found the problem also figured out how to fix it. So they figured like they just found a different metric for how sick patients were. It was actually pretty simple. It was just like number of active chronic conditions. And then they worked with a company to sort of retrain the system to predict that instead of expected costs. And that like led to like a huge drop in the amount of bias. So there's something very good about using automated systems to make decisions, which is that you can sort of systematically measure and intervene on their behavior to bring them more in line with the results you want. And so they're like, it sort of like makes the problem of bias in AI systems in a way more tractable than the problem of bias in human decision makers. I don't know. I think my line on this, in most moods, I think, what should we do now? I think in a lot of these high stakes contexts, we should probably be using simpler AI systems that are easier to understand and control. At least in cases where you can achieve comparable, something like the performance you get from the more sophisticated systems. So this is sort of Cynthia Rudin is a computer scientist at Duke, who for a long time is saying, stop using these like complicated black box systems to make these high stakes decisions. You need to at least see if you can make an easy to understand AI system that does about as well. And her research has sort of often found that that is possible. I think this is changing though. So I've like some of my colleagues who are like more up to speed with the latest technical developments. It looks like the performance of the deep neural networks is in a lot of cases like just continuing to get better. So I think for now it's often like a good option to use the easier to understand systems. There's going to be a lot of pressure to use the more complicated ones as they just get much better at like really important tasks, like what's the best drug to give this patient?
The implication of human use of AI systems on the idea of our judgment.
Yep.
Give the example that's running in my background, and then maybe you can speak to this. And the recent MIT study of students writing with
love this
chatbots,
yep.
Writing brain only is how they described it, and then writing with resources like Google.
Yep.
And one of the findings from that study, not to our surprise, right, is about brain activity and what they call cognitive deficit. So a limited amount of brain activity when we're producing with chatbots. Okay. But my real interest is in whether or not people felt responsible for the words they produced.
Right.
So I'm wondering about the leaning towards the humans using AI anyway.
Yeah.
Right? And then what implications that has for our understandings of how human judgment.
Yeah, so I think they measured that, right? Like, yeah. So I think they had students use chatbot, write essays using chatbots, not using chatbots, and the students that used the chatbot said, "I don't feel as responsible for this," which is sort of that's sort of what you would expect, and also kind of a relief. Yeah, I mean, I don't know. I don't know that this is going to directly answer the question, so you can sort of like restate it if it doesn't. I mean, it's not as if I think so. These are sort of like I think like in a lot of cases, having a like human with expertise and experience make a decision currently does a lot of really important things for us in institutions. It plays lots of important roles. It's not as if I think that the only way you could achieve a lot of those goals is to have like someone with like advanced degrees making the decisions themselves. I think there probably are ways to redesign things. So a lot of the decision making is automated, but we still get those goods. But I think we don't know how to do that. And I think the real risk is that you just start, I mean, what's likely to happen is you just start deploying things, right? Like, so you just sort of like, all right, doctors, you're going to start using chatbots to diagnose patients. And then like lots of side effects. Yes. So, and then lots of like lots of bad things are going to happen to institutions. they're going to lose a lot of these capacities. But that's not inevitable, right? I mean, I think like, if we can manage to proceed more slowly, we can figure out how to like exploit the sort of considerable power that these technologies have in a way that, maintains important social relationships between the institution and the community, that like, maintains like sort of like deserved trust and authority. But yeah, it's going to be really hard to figure out how to do that. And we're only going to be able to do it if we go pretty slow. Yeah.
Got one big picture question. Sophia Biodi and I had a conversation about the relationship between imitation and simulation. Sophia, I think, said in the chat that these systems, artificial systems, both imitate and simulate.
Yep.
She clarified by imitation, she means imitation. So the way that we do, we imitate some formal reality out there. And simulation is something else than that.
Okay.
And I wondered if you had thoughts on this.
I'm getting out of my depth with Plato questions. I'm going to say some stuff about how I think there's an important distinction there. I don't know if it's the one that she has in mind. So maybe she could follow up. Yeah, I think there is an important distinction between imitation and sort of the marketplace sense, where that just means sort of like managing to act in a way that's behavioral, like sort of indistinguishable from the outside. So like chatbots are very clearly good at imitating lots of pretty sophisticated human capabilities in that sense, where they can sort of behave as if they're doing what we're doing. And I guess I think of like sort of simulation or maybe emulation as not just sort of like appearing to be doing the same thing we are, but instead to actually be doing it in a way that's quite like we are. And I think like, the initial line that was very popular among the computer scientists on this was that these systems were really just imitating. So a lot of people would say they're like stochastic parrots. So there's like nothing resembling cognition going on. It's just like a bunch of like sort of fancy statistics on large like linguistic data sets. That view has fallen out of favor partly because of experiments like the one I talked about earlier. So it looks like often the way that chatbots are like doing a lot of these things is by like sort of learning algorithms. So they're sort of like learning like efficient methods to solve various kinds of problems. In some cases, those algorithms, at least, there's like stuff about how deep neural networks recognize images. And in some cases, like when you figure out how the systems are like performing a task that the human brain also performs, you find that it's sort of like using pretty similar strategies. So like a simple kind of computation happening in the AI system as in humans. So yeah, I mean, I think like, open question to what, I keep using that word, but open question to what extent when we see sort of like seemingly sophisticated reasoning in the systems, how much of that is something like pretty crude, like bagging together a bunch of heuristics, and how much of that is that the systems have actually learned algorithms that are the kind of algorithms that the human brain is running when it does these things? I mean, no idea. But I think that's probably, I don't know if that's platonic imitation, but yeah.
Yeah, I don't know that that's.
Yeah. Yeah. Yeah.
Other questions, please?
Uh-huh.
Ideas or things like that. And my question would be,
I think that's just completely, I think it's completely depends on how you use it. I mean, I don't know, there was a period where I was trying to learn some concepts from statistics that I needed for like writing a paper about algorithmic fairness. And I was like using ChatGPT pretty heavily because I would sort of go and I would read these papers by statisticians, but they would sort of like outpace my level of sophistication. And so like, you can use sort of chatbots in those contexts to sort of like get to those knowledge gaps. So you can find out like, well, where should I look for the information? Often like they can give like quite good explanations of technical concepts. I mean, that's not so much in the sort of like, I mean, it depends on what you mean by creativity, but I was like trying to do that to like figure out research problems in a way that we sort of like traditionally think of as like somewhat of a creative endeavor. And I think that sort of usage like doesn't just increases creativity. It doesn't undermine it because it sort of like extends your capacities in a way that you can sort of figure out things you couldn't have figured out before. On the other hand, like there are definitely ways to use it that like destroy creativity. So like, like these papers from, no UF student would ever do this, but students at other institutions, use chatbots to like write an essay that seems to reflect like a great deal of like philosophical insight, but like, really like probably the student didn't have much to do with it. Like it's, and I think I think it's easy to slip into the habit of over relying on these systems for both like any kind of intellectual task. And so there's definitely a danger of sort of inadvertently de-skilling yourself. So inadvertently getting to where you're sort of doing a lot of tasks that previously would have required you to sort of think hard. The more you get a chatbot or anyone really to do that for you, the less you're practicing those skills. And it's use it or lose it. I mean, I don't know, like there's these like de-skilling happens really fast. So it turns out that like physicians, if they like, stop seeing patients in the clinic, they sort of like rapidly degrade in their ability to do that effectively. Like studies with pilots show similar things. So this is like a general fact about human cognition. If something's hard and you stop doing it, you get worse at it. And so like you could, that's one of the real risks with chatbots is that we all start using them in ways that seem helpful and beneficial, but in ways that sort of leave us less capable. That's sort of one of the morals of, I think this is what the MIT study authors were really trying to get at. Like even if you see short-term gains, that's not really what we're trying to achieve in education. We're trying to build capacities.
To me, that sounds like a great place to stop. It's a little bit depressing. But
Well, that's kind of my job.
That's great.
Thank you. Thank you all. This is great.
Thanks everybody for being here and everybody online too.